NASA's rescue mission needs a rescue, a Falcon 9 rocket is about to crash into the moon, Amazon files to launch even more satellites into orbit, and Boeing Starliner may finally be on the mend? As always, we've got all that and more coming up this week in Spaceflight. Dragon has been ferrying astronauts to and from the International Space Station for 6 years now. It's easy to forget that for a while, it was also racing another capsule to its first crewed flight. That capsule is, of course, Starliner. Now, we haven't heard about it in a while, but this week we've finally got something to talk about. Now, just in case you need a quick refresher, both SpaceX and Boeing were working on the US's next ride to space with their Dragon and Starliner capsules, respectively. Both programs have had their fair share of setbacks, but Dragon has been flying regular missions with no major issues since 2020. Starliner's flights didn't go as smoothly, however. The first uncrewed test failed to reach the station after a timing error caused the capsule to fire its thrusters in the wrong direction at the wrong time. The second flight did reach the station, but not without its fair share of propulsion issues. Then, in June of 2024, NASA astronauts Butch Wilmore and Sunny Williams boarded Starliner Calypso for its first crewed flight. At first, everything seemed to go smoothly, but as the capsule approached the ISS, it once again suffered thruster issues. While the astronauts made it safely on board the station, NASA didn't want to risk it on the way down. So Calypso came back uncrewed, and the astronauts made their return journey on the Crew 9 Dragon. Since then, we've learned that they came much closer to failure than we previously thought. In February of this year, NASA classified the incident as a Type A mishap, the most severe in the agency's mishap classification system. Earlier, NASA had already decided Starliner's next mission would be a cargo mission instead of crew, like originally planned, but they didn't set a date for it. Then, back in February, NASA Administrator Jared Isaacman said that Starliner won't fly again, crewed or uncrewed, until it's ready. So, how are they doing? We hadn't heard anything from Boeing in a very long time until they touched on the subject in an earnings call this week. The February report concluded that Starliner has had design and engineering issues since the very beginning. Boeing had allowed components to operate outside their certified limits and even failed to meet a NASA requirement for the propulsion system to be too failure tolerant for deorbit burns. Somehow, that slipped through the cracks until after the first launch attempt of Butch and Sunny's mission scrubbed in May of 2024. Boeing has since been working on fixing the issues. CEO Kelly Ortberg summarized the process during this week's investor update.
The redesign of the Starliner deficiencies is going quite well, and we're feeling pretty good about that. But we've got to work with NASA to align on the launches are going to be both the crewed and uncrewed launches going forward.
He didn't go into much detail, but he did make it sound like Boeing might not be the delaying party for much longer. The problem is that the ISS has a very tight schedule for its visiting vehicle. The orbital outpost has only 2 ports that Starliner can dock to, and at any time, one of them is occupied by the Dragon that brought up the latest crew rotation. The other one regularly hosts another Dragon for cargo missions or during crew handovers. Then there are other missions to take into account, and they don't want to overwhelm the crew by sending up 2 cargo missions back to back. In short, it might be challenging to free up some space in the ISS's schedule when Starliner is ready to fly again. For now, the mission is still set to launch before the end of the year, and from Ortberg's remarks, it certainly seems that Boeing is working to get the hardware ready in time. Whether the stars will align to make it work with the ISS schedule remains to be seen, but there's still a chance that Starliner could fly in 2026. We'll keep an eye on it, just like you should keep an eye on the subscribe and like buttons under this video to ensure that you've clicked them. The mission to rescue NASA's Swift Space Telescope may be in need of a rescue of its own. Catalyst Space's Link spacecraft launched on July 3rd on a mission to catch up in orbit with NASA's Neil Gehrels Swift Observatory to give the telescope a boost. Swift hangs out in low Earth orbit to observe gamma ray bursts and the afterglows that they produce in X-ray, ultraviolet, and visible light. These bursts are some of the brightest things in the universe, and they can usually be traced down to supernovas, the explosions of massive stars at the end of their lives. It studies other kinds of cosmic flashes too. Just this week, a study was published in which the telescope looked at a galaxy 750 million light-years away in the constellation Cetus. In November of 2025, a flare occurred on the galaxy's outer edge, and Swift found that it was a black hole shedding a star. Until a few years ago, astronomers had only seen this happen in galaxy cores, and now they picked one up in the outskirts of a galaxy. The team thinks that this could either mean a dwarf galaxy is currently merging into the bigger galaxy, or the bigger galaxy was the result of an earlier merge of 3 or more galaxies. Anyway, we were talking about Link, the spacecraft set to rescue Swift. So, why does it even need a rescue in the first place? Well, since its launch in 2004, the spacecraft's orbit has been slowly decaying. This is normal in low Earth orbit, as the traces of atmosphere up there slow down spacecraft, and Swift can't boost its own orbit to counteract this orbital decay. Without help, it has a 90% chance of re-entering before the end of the year. And that's where Link comes in. The small spacecraft is designed to rendezvous with Swift and boost it back to its original orbit. Catalyst put the mission together on short notice after being awarded the contract in September of last year. But this week, the mission hit a snag as the spacecraft started spinning following electrical issues. As a result, 2 of the vehicle's 3 reaction wheels are inoperable, and the cold gas thrusters are also not functioning properly. Yikes, that doesn't sound good. And it really isn't good, but we've seen mission controllers get spacecraft out of perilous situations before. Catalyst has already started reducing the spin by having Link fire a Hall effect thruster. As of recording, this reduced the rotation from 9 degrees per second to about 4, and the company believes that they'll be able to get it down even further. Meanwhile, they're working with NASA to revise the spacecraft's attitude control software. If all goes well, Link will rendezvous with Swift at the end of August. So as long as they can get it back to a state in which it can safely approach the telescope and execute its mission, not all may be lost, but they will need to fix this situation swiftly. From a robotic rescue mission in low Earth orbit, next we'll talk about robotic missions to the moon. Let's start off with Blue Origin's Lunar rover. What? You didn't know? So a few years ago, Blue Origin bought Honeybee Robotics, a company that, until then, had specialized in designing robotic systems for spacecraft, including several of the tools carried by NASA's Mars landers and rovers. With Blue's acquisition, the company continued to develop these robotic systems and even stepped up their game to build their own rover. This week, the company announced the completion of the rover's critical design review and showed a video of the mobility and navigation test vehicle undergoing testing at its Lunar analog facility. This rover is a tiny one, for now at least. Ironically, it won't be flying on Blue Origin's own Blue Moon lander, but rather on Firefly's Blue Ghost lander. I guess it just can't escape the blue. The rover will be part of the payloads on board Firefly's 3rd Blue Ghost mission to the moon, currently planned for 2028. In more lunar news, this week NASA announced that it has awarded a contract to Advanced Space to carry out the sequel to the Capstone mission, appropriately named Capstone 2. Capstone was a mission launched on Rocket Lab's Electron back in 2022, which aimed at validating communications and navigation in near rectilinear halo orbit, an orbit that was originally intended to be used by the now canceled Gateway station. So you might think, well, does NASA really need a sequel to that mission? And you'd be completely right, except this second mission isn't aiming to repeat the same profile. Capstone stands for Cislunar Autonomous Positioning System Technology Operations and Navigation Experiment. NASA loves its backronyms. This second mission will feature 2 spacecraft instead of 1, and they'll be performing rendezvous and proximity operations while in cislunar space, so it fits the bill for what the Capstone acronym means. This mission is intended to be launched next year, ahead of the first human landing on the moon as part of the Artemis program. Capstone 2 will use techniques and technologies that will be flying on future missions, automating navigation beyond Earth orbit as it's currently performed, allowing for a reduced reliance on communication with the ground for navigation, and enabling future satellite-to-satellite navigation around the moon. Some of this technology will also be on board NASA's Orion spacecraft, so the lessons learned from this mission, combined with those on Artemis III with the lunar landers, should give the agency enough confidence for the Artemis IV lunar landing in 2028. Now, while NASA's Artemis III mission is technically not a moon mission, it's definitely still important for the overall Artemis program, and we've got another update about it this week. The agency released these pictures showing the next 2 solid rocket booster segments for the SLS rocket staged for transport and ready for stacking. These are the left and right aft center segments, and should be joining the aft segments in the coming days to begin the stacking of the Artemis III SLS rocket. The aft segments had already been placed on the rocket's Mobile Launcher 1 One a few weeks ago, but official stacking doesn't start until these next segments are placed on top. Once all 5 segments for each of the boosters are stacked, a forward nose cone and skirt will be installed to top them off, and teams will move to prepare them for core stage integration. Japanese company ispace has announced that it signed a launch contract with Mitsubishi Heavy Industries to launch its next lunar lander on an H3 rocket. ispace launched its first 2 lunar landers on SpaceX's Falcon 9, one in 2022 and another one in 2025. Those missions didn't go too well though, and they were also with the company's smaller Hokuto R lander design. That older lander design was even small enough to be able to share a launch with Firefly's Blue Ghost lander on a single Falcon 9 rocket. ispace now intends to fly a much bigger lander design called Ultra, which should be able to carry hundreds of kilograms to the lunar surface. The first mission with Ultra is currently set for 2028, and thanks to this week's announcement, now we know it's launching on the Japanese H3 rocket. This would be the first time that a Japanese lunar lander launches on a Japanese rocket. Quite the milestone. It's another week, which means we've got more news from Blue Origin on the process of bringing Launch Complex 36 back online. This week, Blue's CEO Dave Limp shared a time-lapse on social media showing the destack process for the Vehicle Access Tower at LC-36. He explained that the destacking of this tower has now been completed and that they only needed to remove the top 6 modules of it to get it back on track for flight. These modules will be fitted with new cryogenic and pneumatic lines, control mechanisms, and access floors that will help to support the new concept of operations from this pad. It's interesting that as part of this destack process of the tower, Blue decided not to remove the module that was damaged during the New Glenn explosion back in May. Based on this, it's not hard to guess that they'll repair that part of the tower in place. After sharing that time-lapse, Limp also shared a picture of the repairs being done to the integration hangar at the base of the LC-36 ramp. In particular, the picture showed teams installing new doors for the hangar's north side. This side is the one directly facing the launch ramp, so when New Glenn exploded, it took the brunt of the explosion and the hangar doors were damaged, thus needing a new set of doors. Limp also mentioned that the opposite side, the south side, should be next for installing new doors. So from the destack of a launch tower to the destacking of a rocket, next we go to Saxavord in Scotland, from where Rocket Factory Augsburg plans to launch its RFA One rocket. On last week's episode, we talked about this rocket being stacked and on the pad, but the news this week is pretty much the opposite. A few days ago, the company announced that it had successfully performed testing of the rocket on the pad for the first time, but that they had encountered an issue that will require a closer look. Because of this, the company has decided to destack the rocket in order to conduct the necessary investigation. What's interesting is that there were indications of the launch happening quite soon. So now with this issue and the investigation underway, all timelines have probably shifted to later dates. We'll be keeping an eye on whether more information becomes available either from RFA, the Saxavord spaceport, or any other indicator. It's understandable to see this company taking it slow with their pre-launch campaign, given what happened 2 years ago during a static fire test of the booster on that same pad. Way better to have a destack than an explosion. Another company getting ready for the first flight of its rocket is Stoke Space, and this week it showed off the first 3 Zenith engines for Nova's first flight. The engines, with serial numbers 14, 15, and 16, have completed production and will be shipped to the company's test facility at Moses Lake in Washington. It's interesting that these 3 engines for Nova's first flight are 14, 15, and 16 because the latest engine test footage that Stoke showed had Zenith engines 12 and 13. So it means that those were the last of the development batch, and now they're getting into flight engine production, which bodes well for a flight not too long from now. Stoke's Zenith engine is a methane-fueled, full-flow staged combustion cycle engine similar to SpaceX's Raptor engine, but smaller in size and thrust. This kind of cycle is very complex, but more and more companies are trying it all over the world, including the Exploration Company in Europe. Usually, the hardest part of this type of engine cycle tends to be the oxidizer preburner. This is basically a smaller rocket engine inside of the bigger engine that burns part of the fuel in order to power the pump that injects oxygen into the engine. The combustion inside this preburner creates an oxygen-rich gas at high pressures and temperatures, so it often needs special metal alloys to survive that environment when the engine is in operation. It's no surprise then that in the development of such a complex engine, the first thing that you'd want to test is the oxygen preburner, which is exactly what the Exploration Company has been doing in the last few weeks since it announced its Storm engine. The company recently released footage of one of these tests, saying that they they've now accumulated nearly 10 minutes of testing with a subscale oxygen preburner demonstrator at the German Aerospace Center's Lampoldhausen test facilities. While these are still early tests, they're necessary in order to build up to a full-up engine, hopefully not too long from now. In more engine news, this week Impulse Space announced its new Electra engine. This engine is not a chemical engine like the ones the company has produced in the past, but rather an electric propulsion thruster. According to Impulse, it took the company less than 6 months to go from clean sheet to firing of the first Electra engine. Impulse says that the use case and the reason to develop this engine is in order to complement its existing chemical propulsion portfolio, allowing for different kinds of propulsion depending on customer needs. Chemical propulsion is high thrust but low efficiency, whereas electric propulsion is the opposite. Low thrust and high efficiency. The hybrid approach allows for the use of the electric propulsion for slow maneuvers prolonged in time, such as orbit station keeping, while keeping the chemical propulsion for the fast and shorter maneuvers such as orbit raising and plane change. Impulse Space says the first flight of Electra will be next year as part of the company's RFA One mission to geosynchronous orbit. Right now the engine is still under development and carrying out qualification testing prior to integration with Impulse's Mira transfer vehicle. From news about engines, we go to some other stories across space, the first of which doesn't involve an engine just yet. This week, Europe remembered that it had a reusable rocket prototype out on a pad ready for testing. Ariane Group's Themis vehicle arrived at Sweden's Esrange Space Center for testing in the fall of last year, and we hadn't heard anything about it until this week. Now, of course, that doesn't mean that they haven't been doing anything in all of this time. Since then, teams have verified the interfaces between the ground systems and the rocket in a series of tests culminating in a wet dress rehearsal on July 23rd. During this test, teams loaded the vehicle, not with its liquid methane and oxygen propellants, but instead with liquid nitrogen, which provided a safe way to test the pressurized systems at cryogenic temperatures as low as -200°C. The test lasted a full day, during which they ran through the entire launch countdown, as well as post-launch operations to safe the site. They even tested the system passivation procedures that will happen after landing. This successful wet dress rehearsal completes an important milestone towards Themis' first hop test, during which the rocket's Prometheus engine will lift it up to 100 meters. Then it will throttle down to descend and land softly. That flight is supposed to happen later this year, but considering the pace at which things have been happening so far, we wouldn't be surprised if it takes just a bit longer. Either way, we may not hear about this again for a while, but we'd love to. This is a cool project that we'd really like to share with the world. Over in Florida, NASA is getting its Nancy Grace Roman Space Telescope ready for launch. Recently, technicians loaded it with over 1,000 liters of hydrazine fuel. Hydrazine is nasty stuff, so the team wore protective suits during the procedure, but the advantage is that it's very stable, which means the telescope should have more than enough fuel to last its planned 5-year mission, and likely enough to last another 5 years on top of that for a mission extension. The hydrazine will power Roman's thrusters, which it will use to point its solar panels at the sun and stay in its orbit around Lagrange Point 2. From there, the telescope will use its wide field of view to study large swaths of sky, looking for exoplanets and trying to shed some light on dark energy and dark matter. Next up, the spacecraft will be attached to the payload adapter that will attach it to the top of Falcon Heavy and encapsulated in the fairing that will protect it during launch. We expect it to launch no earlier than August 30th, 9 months ahead of schedule. How amazing is that? Russia's sending its Angara rocket to the endless forests in Siberia. Rocket production is on its way to the Siberian city of Omsk, but the road taking it there is long. Very long. So, Angara is one of Russia's new generations of launch vehicles. It's booked several successful flights in recent years across multiple variants, and its first variants are pretty much operational now. But considering the program started in the early 90s, it has been particularly slow to get off the ground. Now, Russia wants to move its rocket production to Omsk. Actually, there's really no news there, as they've wanted to do this for a long time. So long, in fact, that it wasn't really clear whether they actually would. But this week, they once again committed to the move, with head of Roscosmos Dmitry Bakhanov visiting the new factory. They're now aiming to complete the move by 2029, a full 20 years after they started it. Will they make the deadline this time? Well, the Angara program isn't in a particularly good state, just like the rest of Russia's space program these days. Angara has been facing cost overruns, contractors going bankrupt, and arrests for alleged defrauding of hundreds of millions of rubles, all just this year. Honestly, the fact that they've been at it since the 90s and have only been getting operational in the last few years should have been a bad sign. It's not too long until 2029, but who knows what might knock the program off balance next. Omsk might be a nice city, but for Angara, it could end up being just a smidge too far away. Amazon may have only launched the first few hundred of the 3,200 plus satellites of its LEO internet constellation, but it's already looking to add more. Thousands more. The current LEO constellation aims to deliver high-speed internet around the globe, just like SpaceX's Starlink, with users needing a special antenna to connect to the satellites. But now, Amazon has filed for a new constellation of 5,105 satellites that connect directly to mobile devices. Again, we've seen something similar with Starlink, which has a direct-to-cell offering. To enable global coverage, Amazon plans to distribute the satellites across 5 shells at slightly different altitudes. The first 3 shells will have an inclination between 55 and 60 degrees to cover mid-latitudes, while the 73-degree shell 4 should cover high latitudes, and the 5th 84-degree shell will enable near-polar coverage. Enabling this constellation is Amazon's recent acquisition of Globalstar, which has spectrum licenses for the radio frequencies that Amazon plans to use for its direct-to-device constellation. The company has now filed with the Federal Communications Commission to start deploying the constellation in 2028. With so many satellites needing to be launched, we'll have some good years ahead for fans of rocket launches. Speaking of which, this is your weekly space traffic report provided by NASASpaceflight. This was a quieter week in launches than what we're used to, with only 3 launches so far. 2 of them took place from China, with one carrying a space telemetry and data relay satellite, and the other one carrying a pair of classified communication test technology satellites. The 3rd launch came from the United States with another classified mission, NROL-95, in support of the National Reconnaissance Office. While little details are available about this mission, we do know that it carried just one payload. Based on the orbit it achieved, it also must have been very similar to the payload on the NROL-77 mission from last year. At the time, the payload was theorized to have been a Naval Ocean Surveillance System satellite, an electronic signals intelligence satellite for the US Navy, so chances are that this one is for that system as well. Now, it was a bit of a slow week, but hopefully next week will be a bit more active. For instance, up in space, we're gonna have a crash. Now don't worry, it's fine. It's just that a spent Falcon 9 upper stage that launched a pair of lunar landers last year is on a path to collide with the moon next week. The impact is expected to occur on August 5th at 6:34 UTC, and it should be near the limb of the northwestern corner of the visible side of the moon, so it could be visible to observers on the ground, if you've got good enough equipment, of course. Next week, we'll also see the first of a trio of spacewalks on the outside of the International Space Station to improve power and communications on the orbiting outpost. On this first spacewalk, NASA astronauts Jessica Meir and Anil Menon will spend about 6.5 hours preparing the station's 3B power channel for the installation of a new rollout solar array later this year. Down on the ground, we could see up to 6 launches going spaceward next week. 3 of them are expected to be Falcon 9 launches, with 2 of those being Starlink missions. The 3rd Falcon 9 launch of the week should be the launch of a trio of Bluebird satellites for AST SpaceMobile. We also expect there to be 2 launches from China, one of them likely in support of the country's Qianfan internet satellite constellation. Japan's H3 rocket will make an appearance as well with the launch of the Michibiki 7 satellite, a navigation satellite that's part of Japan's quasi-zenith satellite system. This will be the first H3 launch in its 2-engine configuration since the loss of the Michibiki 5 satellite last December due to a structural failure of the payload adapter. Now, as can happen with future launch schedules, things can always change, so make sure to regularly check nextspaceflight.com or download the NASASpaceflight app on your phone so you can be up to date. And that's your weekly update of spaceflight news. I'm Alicia Siegel for NSF, and we'll see you all again next week to recap this week in spaceflight.